Let's talk about persisted datasets and how this tool in Rock can leverage Lava to make your website scale and also be very performant. Before we talk about the technology though, let's first talk about technical empathy. And that's really the concept of understanding what we're asking the computer to do. With every instruction that we give it, it's important that we know the pressure that we're going to be putting onto the computer. I love this icon. I feel like it encapsulates exactly the concept of technical empathy, that we really have to have our mind on that computer. Every single line of Lava or every single piece of configuration that we do in Rock, we have to understand what we're really asking Rock to do and to really consider, is there a better way? So if you've watched some of our other videos, you've probably seen the video on caching. If not, I would almost recommend that you just stop and go watch that video. But just to give you a little bit of a reminder of what we talked about, we're trying to compare the instructions that we give computers to distance in more of a human mindset. So we talked about how if we want to go get something out of RAM, which is kind of where the cache normally lives in RAM, it's really telling the computer that you have to walk 100 feet to go get it. So that sounds like a long distance until you start considering the other things that we might be telling the computer to do. For instance, if we want to do a simple database read, and I mean simple, just like dead simple, we're asking it to go 500 miles. And a complex database read can easily be almost 4,000 miles. So that quick trip to RAM actually seems very, very, very short compared to those times. And so we need to kind of keep this in mind as we start kind of going through this process. Let's first start with an example. So say we had some very basic Lava and all we were doing is loading onto our web page some information about some events coming up. So in this case, these are kind of ads. Think about these as ads for a website. They might be events, they might be something else. So we're using a content channel because we can put pretty much any type of information that we want into the content channel. And all we're going to do is to show the title of the content channel. The content channel has an attribute of which campus it's going to be at. And then the campus is going to tell us which event coordinator is for that campus. And so let's just picture that we have 30 different events that we're going to put on the screen. Okay. And this is our kind of our example output that we want. So let's look at how we're going to do this. The first thing we're going to do is we're going to go to our content channel. We're going to get the promotions, and there's 30 of them, and we're just going to put those onto the screen. So if we look at it from what are we asking the computer to do, we're basically asking it to make one trip to the database. And this is maybe not a simple read from the database, but it's not overly complex. So let's just be conservative and say this is 500 miles for the computer to travel. And our Lava for this, nothing fancy. I mean, any of you who know how to do entity commands would be very comfortable with this. We're just doing an entity command for content channel ID 18, and we're just going to load the items and show the title. So far, we're doing pretty good. We've only asked the computer to make one database read. Not too bad. But remember, we needed more. We needed to present the event's campus. And so the campus was an attribute on the content channel item. So we'll go ahead and get the campus for this. And now what are we asking the computer to do? Well, we actually are asking the computer to go out to the database 30 times to load the campus for each item. So we went from one database read, now we're up to 30. And if we look at the Lava, again, this is pretty standard Lava that I'm sure a lot of you have written. So we're up to 31. Now we're getting kind of concerned here. We've asked the computer to go take that 500-mile trip many, many times. It's probably not too happy with us right now. But we're not done. We still need to get the event coordinator, which is an attribute on the campus. So you're probably thinking you might know what the right answer for this is, and you might be surprised it's actually 91 queries we're up to. Now you might be thinking, wait, what happened? We went from 1 to 30, so adding the campus added 30 queries, and then adding the event coordinator actually added 60 queries. How's that possible? Well, we lucked out with campus. Okay, so campus is an entity that's actually in cache. So we made one read for each item to go get the attribute value, and then we could convert that attribute value into the campus object by reading out of the cache. We kind of lucked out on that one. Now, obviously, people are not stored in cache. That would be a lot of things in memory to have everybody in your database in cache. So we had to make one database query to do the attribute value read, and then another database query to convert that into a person. And that query actually to convert into person is not necessarily a simple query, but again, we'll be conservative and say that's 500 miles. So now we've taken that 500-mile trip 91 times. The computer right now really not too happy with us. Here again's the lava. Again, nothing, out of the ordinary on this lava. But maybe we want more. Maybe we want photos, and maybe we want to actually show the phone number for the coordinator. So again, we're adding more and more information that we have to go. And if we wanted to have all this information on the screen, adding in the photo and the phone number, we're up to 156 database queries. You can start to see how this can add up. And what you'll notice is if you were to load this lava, you probably would think, oh, it's loading actually, not too bad. It's not too slow. So speed is one thing, but scale is another. If you had hundreds or thousands of people doing this all at once, you're going to run into some trouble with that. Okay, so why is this? Well, Rock is a very extensible system. You can add attributes to anything. You can do workflows. You can do all this extensible things. You don't have to write code. You don't have to compile the code. You don't have to be a programmer to really create these rich experiences and applications. The extensibility of Rock is what makes it great. But sometimes extensibility and speed can be in conflict with each other. It's hard to have really, really, really extensible systems and still have blazing fast performance. But with Rock, it actually is possible. But to do it, you have to add a little bit of extra configuration at times. Not always. Sometimes things are going to be very fast and you don't have to do anything extra. But when you start reading on attributes of attributes, or you start making these kind of rich experiences with these extensible tool sets, you do need to add some configuration. Your first tool that you should go to, and the easiest tool to go to, is cache. So go back to the caching videos on how to use cache within Rock. Those are going to be your easiest tool sets to make things go fast in Rock. But sometimes you need to go even further, and that's where we're going to talk about this new tool called the Persisted Dataset. But before we get to that, let's just talk about why this extensibility can be slow. And it comes down to a term in programming called lazy loading. So as you write your lava, the computer doesn't quite know where you're going. So it knows it's on a trip with you, but it doesn't really know where on the map you're driving to. So we can't just get all that data that you want from the very beginning. As you start iterating through your promotions and you saying, hey, now I want a campus. Oh, it's like, okay, I'll go get that. Oh, and I need the campus coordinator. Okay, I'll go get that too. So that's kind of lazy loading. It's lazy in the sense it's going to go get it as you ask for it, but it doesn't quite know everything you want ahead of time. Now, the opposite of lazy loading is eager loading. And so eager loading says, hey, you just tell me everything and I'll go get it. Eager loading is not very extensible, though. You have to tell it exactly everything ahead of time, and you have to compile it, and you have to be much more structured with it. It's much more rigid and not very extensible. And the example here of the beavers is a perfect example, because beavers, if you know about their lifestyle, they spend all summer storing up trees and limbs, and they put it into the lake, because when the lake freezes over all winter, they're going to be eating off of that bark. And so they store up their things. They gather it all, and then they eat it. And so eager loading is great. You say, why don't we always do that? Well, it's not very extensible. It's very rigid. So in Rock, you can actually have your cake and eat it too. So you can take the lazy loading concept and create these eager loading models, which are what we call persisted data sets. Okay, so back to our example. Remember, this is all the data that we need. And what we're going to do is we're going to kind of bind all this together in a definition ahead of time in our persisted data set. And we're going to persist that data together so we can get all of it very quickly in at most one read. So how do we do that? Well, we're going to create the persisted data set, and that is made of Lava. So Lava is the template that we're going to use, but instead of writing out HTML right away, we're going to use that Lava to actually create JSON. So JSON, it looks complex. It's really not. It's just a way of structuring or kind of describing the shape of the data that you want to create, and then giving it the actual data that you want to store. Okay, so we're going to use Lava to create JSON, and then we're going to use that JSON to create our page. And so let's walk through that. Okay, so this is our JSON. This is the actual results of the Lava template. We'll create something like this. And as you look at it, it's not that hard. I mean, you have properties, like the event name is a property name, and then the value would be starting point. The campus, we've actually put the full name in here. And you can get the URL for like photos and put the coordinator name, email, person ID, and you can continue on. You can put as many of these properties as you want. And so what we can do with this JSON, our Lava will make this JSON for us, and it'll then store it into the database for us. And now we can read all of that in one database read, and one very simple database read on top of that. Optionally too, we can actually store this data in memory, in cache. So that's even faster. So we can store it 500 miles, or we can store it 100 feet away. And even the 500 miles is a great performance boost, because we're only getting it once, remember, versus 151 times. That's pretty great. But either way, it's up to you. We'll show you how you can do it how you can configure it in either way. So let's look at some Lava that is going to help us create this JSON. And it's actually much simpler to do. But here's the configuration. So we go to add a persisted data set. That would be under CMS configuration. And we're just going to provide it a name, just a friendly name. Just use it anything you want. We're going to provide an access key, and that's how we're going to know in Lava how to go grab which persisted data set. So that's kind of like an attribute key. It's an access key for the persisted data set. Then our Lava script is going to go right in this text editor field. And then down here, we configure the Lava commands just for security, much like you're used to in every place else in Rock. And then finally, we have some configuration. Okay, so let's look at that configuration real quick. Down here at the bottom, we can see and set how often we should refresh this data. So it's basically on this interval, how many hours we're going to go take that Lava, we're going to go update the JSON. What's nice about this, in cache, if you remember back, the first person to load the page pays the penalty to actually build the page, and then it gets cached. This is actually nice because it's on a schedule. So there's a Rock job that's out there, rebuilding this persisted data set on that schedule, and no one has to pay that first load penalty, which is pretty cool. Next is, how long should it be kept in memory? Now, you don't have to put a value here, which means that every time it goes to get it, it's going to go get it out of the database. But you could choose to say, hey, put it in memory too, which would make it super fast. Now, this duration is a sliding scale. So if you say like 1 hour and someone's loading this data, like say every 20 minutes, it's actually always going to be in RAM, because in cache, because it's only going to leave memory when it's been in 1 hour and no one's asked for it. Okay, so every time someone asks for it, it kind of resets the clock on that 1 hour, which is very nice, because if it's heavily used, it's going to stay in there, and if it stops being used, it'll kind of fall out of memory and release that memory to go do other things. On the right-hand side, it's going to allow you to tell you, to let you describe what the entity type is, and we'll kind of look at that a little bit later. That's optional, but there are some pretty cool things you can do if you tell Rock, hey, the entity type for this persisted data set is a content channel item, or maybe it's a list of groups or something else. Then down here, you have a date that says, hey, this persisted data set will expire on this date. This is kind of a helpful property, because in some cases, your persisted data set might have a shelf life. So maybe it's something you're doing for a specific event that's coming up in 3 months. And if you're like a lot of us, you might forget to go undo this persisted data set. And so what this allows you to do is say, hey, stop updating it on this date. And so that's going to relieve Rock from having to go get the updated information and keep putting it in there. So that's just kind of another little nice property to help you so you don't have to keep a mindful watch on all of this. So we said that we would talk about the lava. So this is the lava to create the persisted data set. So it's actually just creating JSON. So if you look at the lava, it's not much more complex than we had before. Okay, there is a little bit of syntax that you have to have in here. Okay, so we're going to look at this. So basically, you're creating JSON. There's some great videos on YouTube if you want to get an introduction to JSON. It's pretty easy though. But one of the things that we need to do is we need to define the key and the value. And so I've highlighted here an example. So in the beginning, we're going to get the ID. So that'll be the item ID, the content channel item ID. And notice here that the value doesn't have any quotes around it because we know the ID is going to be an integer. And in JSON, you don't have to have quotes around integers. But if I kind of go down to the next line, you might say, well, but the title should, because the title should be a string. A title should be a characters too, alphanumeric characters. And I know in JSON, you got to have quotes around that. But if we use the toJSON filter, Lava's going to take care of that for us. It's going to say, hey, this thing's a string. I better put quotes around it. And so it's just a little trick here. You could do it yourself. You could just not toJSON and just put quotes around it. But you got to be careful because if that title has anything in there that's not allowed inside that string, inside of JSON, it's going to throw an error. And if you toJSON it, it just takes care of all that for you. It's going to encode everything just right for you. So we did the same thing with the campus. Now down here, you might look at the event photo URL and say, well, why didn't you toJSON that? I could have, but the way everything flows together, I would have had to make another assignment variable, and it was just more trouble than it's worth. I know it's going to be a string, so I put the quotes around it. So you get to kind of choose how you want to do that. The last thing I want to point out down here is this cool little trick using the unless command inside of Lava. Basically, it's just saying, hey, there should be a comma after each one of these items, except the last one. We don't need a comma on the last one. And so this quick little snippet kind of does all that logic for us. Before, if you didn't think of this little trick, you might be thinking of having to do a whole bunch of if statements to determine if it's a comma should be there or not, or maybe you put a comma and then you go back and strip the last one off. This is super simple. Neat little tool to put in your tool belt for making JSON. So again, the Lava here is pretty simple for creating JSON. And we just put that inside of our configuration and we're all set. So I hope you see that creating these persisted data sets are actually pretty easy. And not only do they give you better scale and better speed, there's also other benefits too. So again, the access key that we're going to be using to use this persisted data set is right there. So keep that in mind. We're going to see this in our next Lava. Let's actually start using this persisted data set. So here's the Lava now that we want to put on our page to get the data and put it out there. So again, we're just going to create a variable called events. We're going to use the access key event listing and just pipe it through the filter persisted data set. And that's going to actually go out there, load that data from the persisted data set, and now we have it. And then we're just going to iterate over the items in there. All of this can be done in at most one database read, but if it's in memory, no database reads, and it's super blazing fast. So your pages will load very, very, very quickly. Okay, so lots of different options. When we create our persisted data set, we have it there kind of in memory. And we said, hey, it can speed us up, it can provide more scale, but it can also save us because we can reuse the logic in multiple different places. So I create that one persisted data set. I can use that on my website. I could use that inside of Rock Mobile. I could use that in lots of different places. Perhaps you want to use it all over your website. Before, you'd have to probably reuse the same Lava template or make a short code or do an include, and all those things are still great. But the persisted data set gives you another place where you can put in a single set of scripts that you get to reuse over and over and over again. So there's just a lot of benefits to doing this. So So far we're going fast, but now something else that can kind of slow us down a little bit as we start to personalize our web pages is some of the personalization, and especially knowing who's following which content. So as you get more mature in your usage of Rock, especially on your websites, you're going to want to start to have people follow content. So if you remember back to some of the Rock conferences that we've done, we've allowed people to follow different things on the web and on mobile to say, hey, these are the sessions I care about. I'm interested in these sessions. I want to kind of keep them on a little short list. And so we use the following models within Rock to do that. So when someone follows a piece of content, we put it on their little short list. Sometimes that can be a little slow if you don't get it right. And so persisted datasets actually help you to make this even faster also. So this is the same exact lava with a few small changes, and those are kind of in darker text. And so basically we're just going to go get our persisted data set. We're going to pipe it through append following. And so as long as I've gone into my persisted data set and I've marked the entity type, it's going to say, hey, the current user is Ted Decker, and append onto the results those records, whether they're following this record or not. So in the event.isFollowing, if I've created some kind of mechanism for them to follow, it's going to say whether or not they're following that specific promotion, which is really cool. Super fast, and it gives you this nice following feature. So that's pretty cool, but we can even take this a step further and say, hey, on top of that, filter so I only see the followed people. So maybe you don't want to have to put an if statement in there and say if is following, put this in. You just want to say, hey, just give me the ones that they are following. Another little shortcut is just to say filter following, and so it'll only show the ones that they are following. So those are some two little tricks that you can add on to your persisted data sets, kind of advanced, not often used, but as you get more mature again in the following of content, you're going to find that those really, really save you a lot of time and are very performant. Okay, so I hope you've seen that persisted datasets are a great tool to put in your tool belt to take the extensibility of Rock and make it very, very, very fast.